Hello, ladies and gentlemen. My name is Joshua, and it's my pleasure to welcome you to this introductory class on how to use ARC software to teach matrix algebra. We need just one package, that is Mathlib. Let us load the package, library Mathlib. And the first thing we want to learn is how to create various types of matrices in R. Let's start with your row vector, that is a matrix with just one row. Let's say A equals to matrix. Let's say we have 2, 4, 7 as your row, which means we have 3 columns. So we have n col, that is number of columns, equals to 3. So run this and check your results. So clearly we can see that we have 3 columns and 1 row. Next, we want to look at how to create a column vector. For a column vector, we have 3 rows and 1 column. So in that wise, you have matrix C247. So instead of number of column, here you have n row, indicating number of rows. So let's run this. So here we have 3 rows, 1 column. For a square matrix, which is a matrix with equal number of rows and columns, let's illustrate by creating a 2 by 2 square matrix. So we have a matrix, and please take notes. It's going to arrange it by color if it is done this way. So which means 2, 1 will be the first column, 3, 5 will be the second column. So this 2 by 2. Run. Check the results. Beautiful. But in case we want the arrangement by row, so in that wise, 2, 1 will be the first row and 3, 5 will be the second row. In that wise, we have to add by row equals to true to the creation of matrix A. So here we have, so A, great. So let's create a 3 by 3 square matrix and arrange the elements by row. Beautiful, super simple. We want to add the row and column names. These adding names of rows and columns. So to add the names, you have, you define as a dim names equals, so that is just what you are going to add. That is the names of the dimensions. So we have list R1, R2, R3, that's column. Now row 1, row 2, row 3, then C1, C2, C3, that is column. So we use lists in order to add the names of the dimensions. Let's run this. So check. Beautiful. So you can see. Yeah, let's try it again. In this case, we have 1 to 9 arranged in terms of 3 by 3 matrix by row. So we add the dimension, the names of the dimensions. So run this. Beautiful. Yeah, instead of R1, R2, you can actually put whatever name you desire. So, and another way of, instead of using list, and this is the one that I prefer because I think it's more straightforward. I create my matrix. So I will say row names, that is for my matrix A. I label it as row 1, row 2, row 3, or if you like, R1, R2, R3. Then call names A. This is the one I normally adopt because to me it's more straightforward. So run this, add the row names, add the column names. Then get the matrix. Super simple. So in fact, I prefer this method to the previous one. Let us go to teaching how to access elements of a matrix. Let's say we have this 3 by 3 matrix arranged by row. If I want A11, that is elements in row 1, column 1. Don't forget it is row, column, row, column. So let's create the matrix. And this is a matrix, which means our A11 will be 2. So run it. That's the way to do it here. Beautiful. Let's look at the result again. This will be row 3, 2. That will be 3. Beautiful. So that is how to do it. Let's move to how to create a diagonal matrix. So if you want to create a diagonal matrix with the same diagonal elements, you use the function DIAG. Run this. Okay. So this is telling us that we have 4 by 4 matrix, that is 4 by 4 matrix, but the same diagonal element, which is 3. Let's see it. Well, in case we have different diagonal elements, we first define the diagonal elements. We say in this case it's 3, 6, 3, but let's say it's 2, 1, 1 for a 3 by 3 matrix. So we say that, then you define the first element here, or the combination will give us the elements along the diagonal. So for a 3 by 3 matrix with different elements, you can see this is 2, 1, 1. So, and that takes us to how to calculate the trace. The function is TRA. So let's create again. So let's create this 4 by 4 matrix. Forget. So, and if you want to get the trace, you know, it's adding the element along the diagonal. This is 3, 3, 3, 3. That's 12. But you need the function TR in order to obtain it. So TRA, that is, you can see 12. Beautiful. Now for the second one, we know it's going to give us 3 plus 1, 4. So TRB. Beautiful. To check equality of matrices, we use identical function. So let's say we have matrix A to be this 2 by 2 matrix. Another B having the same elements, 2 by 2 matrix. And we have C, which is arranged by row. So to check whether A is equal to B, it's identical AB, true. To check whether B and C are equal, identical BC, and we know that is false. So super simple. If you want to create matrix of zeros, let's say you want to create 3 by 3 matrix of 0. So you start with 0, just put matrix there, 0 to 3 by 3. Simple. And if you want to create a unit, or what is normally called identity matrix for a 2 by 2 matrix, let's remember that the element along the diagonal for a unit matrix is 1, 1. For 3, let's say TIAG3. Simple. If you want to create a matrix of constants, we use J. Good. You can see. And we can create it and add what is it called? A diagonal matrix to it. So let's try this. And let's find our A. Beautiful. If you want to obtain the rank of matrix, that is the number of linearly dependent rows or column. It's very straightforward. The function is R. So let's say we have this 4 by 4 matrix, small matrix, and we want to calculate. Let's look at. So this is the 4 by 4 matrix. We want to calculate the rank. Say A. Super simple. So it is 4. Let's create this matrix B arranged by row. So give us this. So let's look at a B. And if you want to calculate the rank, just a B. Super simple. To obtain the transpose of a matrix, you use the function T. So let's create this matrix B. So check it, you know, transpose is replacing the row by the column. So is it, which means the first row will be 1, 2, 3. So let's transpose. Let's see. Beautiful. To create a symmetric matrix, let's create a matrix. You use Symmat. So Symmat. So let's get B so that you know what you have created. Good. So, and get the transpose. We are saying that the transpose and the matrix and the linear matrix are the same. So, which means is a sort of symmetric matrix. Beautiful. So there are other examples. You can practice these examples on your own. Triangular matrix. In order to create a triangular matrix, let us create this 5 by 5 matrix. So now to get a kind of lower triangular matrix, just say M lower dots TRI M equals to 0. That is, we want to change so let's get our M. Beautiful. You can see that the lower triangle, that is all the values below the main diagonal are 0. That is what lower triangular matrix means. If it's upper, very super simple. It means we are changing all the elements above the principal diagonal to 0. So to do that, instead of lower, you change it to upper here. So let's create a matrix 2. Call it M2 here. It's M2. And beautiful. Yeah, great. So that is how to do it. For matrix addition, it's super simple, but make sure that the matrices have the same dimension and the corresponding elements are added or subtracted, as the case may be. So let's create matrix A as a 3 by 3 matrix, matrix B as another 3 by 3 matrix. So let's get our A, get your B. So check your A and B. The first element is 1. For the second is 2. So you add 3. So get your A plus B. First element will be 3. So, and you can equally carry out subtraction. Beautiful. In terms of scalar multiplication, let's say we have this 3 by 3 matrix here, another 3 by 3 matrix. You multiply by any constant, so if that constant multiplied by A. Yeah, beautiful. And you can, let's say we multiply by A and subtract B from it. Super clear. Yeah, for matrix multiplication, let's say we have the 3 by 3 matrix, another 3 by 3 matrix. To multiply, let's get matrix A, matrix B. To multiply, see the function is A percent multiplied by percent B. It's not just A multiplied by B. Take notes. Yeah. So practice this. We have our A1 to be this matrix, which is 3 by 2. And we have our B1 to be this matrix, which is 2 by 2. Take notes. The column, the dimension of the column, the dimension of the rows, they are the same. So the conformability rule is not violated. So it's possible to do the multiplication. So try it. Determinant of a matrix is DTA. It's very super simple. So I have this 3 by 3 matrix. Get this. This is the square matrix here. So determinant is DTA. So 0. So let's get this 2 by 2 matrix here. Get the determinant. 5. And in case you want it to show you the procedure, so you say B, verbose is equal to true, fractions is equal to true. Use cofactor method. So run this. So it shows you how that 5 was obtained. Yeah, you can use the elimination method. You can use eigenvalue method. Whatever method that you have used, you get the same answer. So try as much as possible to work some examples. For inverse of a matrix, let's illustrate how to obtain the inverse using this 2 by 2 matrix. Yeah, the first step is to obtain the determinants. My determinants to be this. So and the determinants. So this is determinant, which is -2. Again, you may want to check how that determinant is obtained. The second is obtaining the minor. So you get the minor for row 1, column 1, row 2, column 1, row 1, column 2, row 2, column 2. So this is obtaining the minors. So get the minor. Yeah. Then to obtain the cofactor, UFA. So cofactor is cofactor, minor is minor. So this is row 1, column 1, so on and so forth. So you have this. So cofactor A. So beautiful. And to get the adjoints, adjoint is adjoint for A. So, and you may wish to look at the adjoints, the GJA. Beautiful. So to get the inverse, you want to work it out, which is 1 divided by the determinant multiplied by the adjoint. So this is just illustrating it manually with the use of R. But for direct estimation, you can just see INVA. If you don't want to go through all those process, but it's good to go through the process that you fully understand what we've done in the class manually. Beautiful. So in terms of application, it's used to solve simultaneous equation. So let's try this. We have minus 3x1 minus x2 equals to minus 2. 2x1 plus 2x2 equals to 1. So generate the matrix A, which is the coefficient of x1 and x2. So we have minus 3, 2. That is minus 3, 2. This is since we are dealing with columns. Then we have minus 1, 2. So this is the matrix. Then generate the matrix of the product. That's B equals to C minus 2, 1. Yeah, you may wish to show the equation. Show the equation. Sit here, show the equation. So this is the equation. You may want to plot the equation. Okay, let me drag this so that we show clearly. Plot the equation. Yeah, you can see clearly. So this is the plot of the two functions. Then solve. Solve is solve. So fraction is equal to true if you want to keep the answer in terms of. So our x1 is 3/4, x2 is equal to minus 1 over 4. Yeah, you can do the same with this 3 by 3 matrix. Yeah. Hey, this should be minus 5z. Yeah, good. So this is 4, 2 minus 1, minus 3, 1 plus 2, 1, 3 minus 5. And it's a sort of 3 by 3 matrix. So run. And you have your B to be minus 10, 0, 17. Can show the equation. Can plot the equation. Yeah, then you know usually the equation will be a kind of 3D. Then you can solve it. So you solve it, your x1 is 1, x2 is 4, and your x3 is minus 2. So, and you can solve it using Gaussian elimination method. If that is what you're choosing, also Gaussian elimination, AB. Get the same results. Yeah. So this is just a kind of telling us how to use R, how to introduce matrix algebra, and to make your teaching very simple. So thank you for listening. And I think we have learned one or two things. Thank you till we meet again.